Okay, guys, number three, April Maths, Unit 1, Paper 2, 2024. All right, let's just run through this. So this one gives us this normal R sin R cos expression. The cos sign is first, that's a cos, that's a plus, that's a plus. So the setup for this is good. All right, this is consistent. The setup for this is consistent with that. And so I'm going to state that the A is equal to 5 and the B is equal to 12 in the expression, and the R becomes the square root of A squared plus B squared, which is equal to the square root of 5 squared plus 12 squared. That's a 5, 12, 13 Pythagorean triple. That is 13. And this works out to be 13. Let's write this better. So we need a 2, 12 squared. And then the alpha that's coming here, I want to give it in radians. All right, the alpha is tan to the minus 1 of the B over the A when the setup is correct. When the setup is correct, I'm going to zoom this up and correct this. This right better. Alright, and then this becomes equal to tan to the minus 1. The B is 12 over 5. Let's get the calculator and do that. Let's find the calculator here. So we're doing in radians. Calculator is already in radians. I'm doing tan to the minus 1 of 12 over 5. That is 1.18. I'm going to work with 3 significant figures and put 1.18 equals 1.18 radians. All right, so that is it. And now that we have those values, let's call this, let's just call this f of theta. So I'm going to say f of theta is equal to that. I'm going to say f of theta, therefore, is the R is 13, and the sine of theta plus, this is my alpha, 1 plus 1, 8 radians. That is it. All right, next part says, hence or otherwise, show that this expression, which are plus 7, is less than or equal to 20. All right, so this expression becomes, let's do this side first. I'm going to show that it's less than 20. So it is this I'm talking about. Becomes, because I'm going to replace this expression with what we have here. And that is 13 sine of theta plus 1.18 radians plus 7. That's the expression. But this expression in here has to be this expression. I can put it here actually. That expression is I'll write it. I'm right up here. The sine of the theta plus 1.18 radians is less than or equal to 1, greater than or equal to -1. So I'm going to say the maximum is 1. So since the maximum value is 1, I show that it is less than 20. All right, so since this is a maximum of 1, then we can say that expression the maximum of that expression is equal to 13 times 1, but this becomes a 1 plus 7, which is 20. I'm just trying to find a way to express it really. All right, that's what it is. So just make this smaller and zoom it up. And I think the key thing that I want to see in this question is that you know that the largest value that this can be is 1. All right, so that's what it is. It has to be less than 20. basically that's it, because this is maximum is 20. And so we can say therefore, I like to make reference, therefore the expression 5 sine theta plus 12 cos theta plus 7 is less than or equal to this maximum. And I did say it's a maximum, which is 20. I think that's good enough. All right. I think that's good enough. I'm trying to think of another way to do it. Thinking of another way. Show you another way you could have done it. Let's express it another way and actually work it out. Let's do it another way. Alright, so I'll do it that way. Let's do it another way, starting from here and adjust. Alright, let's start from here and adjust. So I want to start from here. That we know. Let's make that smaller. We're starting from here. Eh? Let's do it another way. So this is the OR method. This is OR. So we can actually prove this expression by adjusting this inequality that is true. So this inequality is true, and I'm just going to adjust it to what they have said. All right, so looking for another way to do it. All right, it's only 3 marks, but let's go. So what I'm going to do is say this really is equal to this. We know that this is true, but this and this the same. So I'm going to write back this expression for this. That's the first thing. All right. Oh, it's a 13. Oh, that expression is that, but this is equal to 13. This right here is equal to 13. What I can do then is multiply it by 13 first. All right, let's do that way. I'm just trying to use a nice way to do it, right? So if this is less than 1, then 13 of it, remember another expression really is 13 of it. So this expression is actually 13 of that. So I'm going to multiply this by 13. So I'm going to say, therefore, 13 times the sine of theta plus 1.18 radians is less than or equal to 13. And then I'm going to add 7 to both sides. Yeah, I'm going to add 7. Or what I can do is write this back as this expression now. Because remember, it is equal to it now. So I can say, therefore, the 5 sine theta plus 12 cos theta is less than or equal to 13. That's where we have gotten to. So we started here. We multiply by 13, we get to that. But this expression, this whole expression is equal to this. Right? So I'm going to underline those in blue. Right? So this whole expression is actually equal to this, because that's what we did earlier. We went from this to that. And then now I'm going to add 7 to both sides. Now add 7 to both sides. I'm going to get 5 sine theta plus 12 cos theta plus 7. Add 7 to this side, we get the 20 as well. Less than or equal to 20. I think this is a nice way to do it this way. But I think if you do something over here, they'll accept. All right, it doesn't matter. I never want me to solve a question. So let me take this off. All right. Down here, they tell us now, it's actually a different question. Part B, unrelated to the first. It's a different expression, this. They tell us to show that this expression can be written as that. This is actually a transpose. We used to get these questions a lot in GCE many years ago. All right, so normally you have an equation like this, you use the R sign to solve it, but you can also solve it by squaring, but we don't normally teach that method. But this is forcing us to use that method now. So based on what I'm seeing here, I see a cos squared and a cos. So I would I would I want to make it, I don't want to square this side. I want to transpose something and then square. Okay. So let me go and transpose the 3 and leave the 2x. Leave the the 2 sine x as a subject. So I'm gonna write this as 2, please excuse the noise outside. 2 sine x is 3 minus 3 cos x. All right. And then I can factorize the 3 and write 2 sine x is 3 into 1 minus cos x. And then I can square both sides. So now I'm going to square both sides. Square this side and square this side. I can also square both sides. Squaring both sides. So when we square this side, we're gonna get 4 sine squared x equals, when we square this side, we're gonna get this squared is 9. 9. I will square this inside the bracket. We're gonna get the first term squared, which is 1. Twice the product of 2 is minus 2 cos x. And then the second term squared is a positive cos x squared. Let me shift this over. I think maybe I should not have factorized it. Let me change something. It's gonna work still, but I maybe should not have done this. This is what I'm seeing now. So let me take this line out and shift this up. Alright. It would have worked still what I'm doing, but let's just make it easier and square both sides this way. So I'm squaring both sides. Let's zoom up again. Right, so I square this side. I'm going to get this. Then I'm going to square this side. I square that side now. Remember, the first term squared, which is 9. Then twice the product of the 2. So I multiply these two things again. 9 cos x minus 9 cos x. 2 times 18 minus 18 cos x. Then this term squared becomes a positive 9 cos squared x. All right, so this is the trick now. I don't want this sine squared, because there's no sine squared in the solution there. To get rid of that sine squared, it would be nice if I could add 4 sine squared to that. That's just one way to do it. Or write it as 4 minus 4 cos squared. Maybe that's the way to go. Let's do it that way. So I'm going to recognize that this sine squared is the same as 1 minus cos squared x. So the left side becomes 4 minus 4 cos squared x. 4 cos squared x, which is now equal to the entire right side of 9 minus 18 cos x plus 9 cos squared x. Then the equation has everything on the left side equals 0. So I'm going to transpose everything over onto this side. And then we're going to see what happens. Oh, no. I want this to be positive, so I'm going to transpose instead everything over onto this side. All right, so that's what I'm going to do. So I'm going to take this over onto this side and add to the 9 cos squared and get 13. I'm going to get 13 cos squared x. Take this remains minus 18 cos x. And then this 4 comes over and subtract from that 9 and give me 5 plus 5. That is with a 0. All we have done is place the 0 over onto this side. It is the very same expression. to have here. And so I can put this thing equal to 0. So I can just write back, i.e. that is 13 cos squared x minus 18 cos x plus 5 is equal to 0. And that is shown. Alright, that was done. Nice question, nice question. Question says, hence or otherwise, we have to solve this. So remember now, this equation came from that. So to solve this is to solve that. So we're going to use our hence method. To use the otherwise method, we'd have to write this as a r sine x plus alpha. Alright, but that's another set of work. Now know that we want values between negative pi and pi. That's really that we want. So to solve this is to solve this. So I'm just going to use a hence method. And the hence method is now that we're solving this. How can that be factorized? Yes, because I said 13 and 5 give me 18, and the 13 and 5 are prime numbers. So the only factors of 13 is 13 and 1. Only factor of 5 is 5 and 1. So let's go. Factorizing that expression, I'm going to get 13 cos x. Cos x, I need a 5 here and 1 there because I need 13 plus 5. And this equals 0. Signs are the same, they are both negative. So I need a negative 1 and a negative 5. So this one is going to give me cos x equals 5 over 13. And this one, 5 over 13. And this one is going to give me cos x equals 1. And we're trying to find values in this range. So how do I do the negative range? So we find values in the negative range. Sometimes you can find positive values and then subtract 2 pi. But cos is a nice function because you know it's okay. It also is general solution to find it. But let me just shift this around a little bit. Run out of page space. So I'm gonna shift this over some more and then shift this all back up here using the hence method. All right, so it's both of them positive. So generally speaking, we can just draw one quadrant diagram. All right, let's draw a quadrant diagram for this. And cos is positive here and there. So those are the only two quadrants we'll get our answers. All right, so if we're gonna go, so basically positive pi would be this way and negative pi would be that way. But we only want answers positive and negative pi, negative pi by 2, our answer is gonna be. And for this one, we have to be careful with that one. Quadrant diagram for this one, we have to be careful because the angle is 0, cos of 0 is 1. When the angle is 0, you have to be careful. We still only want this and this. But cos of 0 is 1. So the principal angle for this is cos to the minus 1 of 1, which is 0. So the angle is 0. When the angle is 0, it is also 2 pi. Cannot be pi because the cos of pi is negative 1. You can show it on the calculator here. The cos of pi is negative 1. So we can't use that. All right, so the whole angle here is going to be 0. 0 this way, 0 that way. All right, because it cannot be 0 and 2 pi. But we're not going up to 2 pi based on that range. So the whole answer for this one is 0. So x equals 0 here. For this one, the x is going to be 0. All right, because this quadrant would have been 2 pi minus 0. This is our alpha. All right, and we're not going up to 2 pi. And then for this one here, I'm going to shift this over. Our alpha becomes cos to the minus 1 of the 5 over the 13, which works out to be cos to the minus 1 of 5 over 13. That's 1.17, 1.18, 1.18 radians. also remember it is positive angle and negative angle will work for cos, because the negative means that we'll just come in this way and we end up in this quadrant, the same angle. So the x down here is the x down here is going to be the positive and negative of this. Positive, I put negative first, negative 1.18 radians, or positive 1.18 radians. So put the values in ascending order on a solution line. Solution. It's three values. This negative value, this 0, and this. Alright, so put the radians on that. So it's negative 1.18 radians, 0 radians, and 1.18 radians. Those are the answers right there. Alright, that is that. That is that for that question. Alright, nice and easy. Let's move on. Then we'll come to this proof. And I think this is a question that give them some problems as well. But you have to have an eye for certain things. And I can tell you that this expression in here is cos 2x. That's cos 2x here. Cos 2x can be written two ways. 2 cos squared x minus 1. This is also cos 2x. But it can also be written as 1 minus 2 sine squared x. So this is actually cos 2x, and this up here is cos 2x. Alright, so, oh boy. And this is just the difference of two squares. So let's go. So the left-hand side, and remember also cos 2x, these can also be written as this. Can also write it, can also be written as sine cos squared minus sine squared. Right? This can also be written as, but the cos double angle can be in three ways. I tell my students the most powerful double angle, because it can be in three ways. It's also equal to cos squared x minus sine squared x. So these three expressions are the same. They are the same. They are all equal to cos 2x. All right. So left hand side here is equal to, I'm going to write the numerator as cos 2x all squared. Okay, so I'm going to get the difference of two squares in here. I'm actually going to write, let me write the cos 2x all squared. No, I'm going to do it this way. I'm going to write this expression in here as this. Why am I doing that? Because I'm going to get the difference of two squares here. All right, so I'm going to write the numerator, this numerator expression as this, and put a square on it. I'm going to write as, and I'm leaving this on my paper as well. I'm going to write the numerator as cos squared x minus sine squared x all squared over. This knows the difference of two squares. It is equal to cos squared x minus sine squared x times cos squared x plus, shift this over, all right? That's the difference of two squares. Cos squared x plus sine squared x. That's this expression under here can be written as that. All right, because it is the same. This expression under here is the same as cos squared x squared minus sine squared x squared. That's why I'm able to write it as a difference of two squares like that. Okay, so that is that. Then now, what happens is that this out here is equal to 1. This is equal to 1. All of this is equal to 1. Let's put it here. So this expression is equal to 1. And then this expression cancels one of this. So I can draw a line through this. But this expression here and this is the same. So this cancels one of that. And so I am left simply with the result is the numerator. which is cos squared x minus sine squared x. But this is cos 2x still, which can be written as this one, which is what we have here. And that is why I am leaving this on my paper as a part of my solution. All right, so this then becomes 1 minus 2 sine squared x. So somebody tried something with this question. It's pretty straightforward. All they have done is written this cos double angle 3 different ways and to use it, which is the right hand side. Right, so this statement up here, see the space. I'm gonna shift this down and bring that thing in red in as a part of my solution. So bring this down here and bring this in as a part of my solution. All right, using up here, using this, I'm using these, using these identities. Students should know, must know. I want to do these questions easily. You must know your trig identities from left to right, from right to left. Right, I keep emphasizing that. Trigs is easy when you know your trig identities. This question done. This question feel kind of short. Did we do every part of it? Yep, done number 3. All right, what was the next question given problems? Did anybody say anything about the vectors? No, they didn't say anything about the vectors. I might skip this and do this one last later. They didn't say anything about this question. So not number 4. Did they say anything about number 5? No. Did they say anything about number 5? What they spoke about? They said something about number 6. So I think I'm going to do number 6 next. Then I'll come back to 4 and 5 later because I have to have a class with my math students. All right, so I'm going to come back and do these questions. I think I spoke about that graph. All right, and this even function thingy. All right, so I'm going to do number 6 next. All right, so just completing number 3. I'm going to skip over number 4 and 5. They seem to be straightforward questions. I'll do number 6 next. I'll break, keep my class of add math students, and then do 4 and 5 later. All right, so that is the plan.